So today we're going to be looking at story problems, and that is we're going to be taking a look at applications to Pythagorean Theorem converse, as well as 30, 60, 90 triangles. So our very first problem is a 20-foot ladder. A 20-foot ladder reaches a window that's 18 feet high. How far is the foot of the ladder from the base of the building? So let's start with some sort of a diagram. I have a building. A building and some sort of a window. And then I have a ladder that's leaning against it, like so. Now we're told that the ladder is 20 feet. We're also told that the window height is 18 feet from the ground. So because of that, we're trying to find out what this distance is right here. The distance from the wall to the base of the ladder. Now, the ladder's probably not leaning this crazy, so this is definitely not to scale. So I just call that some variable, d for distance, x for unknown. All right, so notice there's also a second part to the question. How far must the foot of the ladder be moved to lower the top of the ladder by 2 feet? So we want to drop it from 18 feet down to 16 feet. So the question is, how far do I have to pull this back? So we'll get to that in just a minute. So the first part is, let's find out. Clearly, I'm going to use Pythagorean Theorem, which is a squared plus b squared is c squared. Why? Because I can assume safely that the angle right here is 90 degrees. That the building is, for the most part, the buildings are, it's not the Leaning Tower of Pisa. Okay, so I see that my c, my hypotenuse, is the 20. My unknown is a or b, it doesn't matter. And the height of the window is 18. Now we can plug all this into your calculator to get an approximate value. And since this is a word problem, it's probably best to have it written as a decimal as your answer. So our result is about 8.7 feet. We can convert that to inches if you so desire. All right, now the next part says, how far must the foot of the ladder be moved back in order to lower the top of the ladder by 2 feet, which now gives us a new diagram. The height now, instead of 18, is now going to be 16. My ladder did not adjust and get longer. It's still going to be 20 feet here. So now the question is, notice it asks us how much we have to move back. So my job is not actually to find out what x is here, and I'm going to change that variable since I already used x. Let's change it to y. The question is not what is y. The question is, how is y different from my original amount? So my original amount over here was 8.7. So I just have to figure out the difference between x and y once I find it. Again, we can assume a 90 degrees here. So 16 squared plus y squared is equal to 20 squared. So y is approximately, and this ends up being a perfect square, so that's actually an equal sign right here. So that gives me exactly 12 feet. Now, the question is not how long is that, but the question is how much the ladder must be moved by. So I have to take this and subtract it from the 12 here. So the actual answer is going to be my distance moved. It's going to be the 12 minus the 8.7. So I'm going to get an approximate value here of 3.3 feet. It's got to be moved back 3.3 feet. Moved 3.3 feet. So looking at number 3 here. Hans needs to paint the 18-inch wide trim around the roof eaves and the gable ends of the house with 2 coats of paint. So whatever we're going to do, we're going to double. A quart of paint covers 175 square feet and costs nearly $10. A gallon of paint costs $27.95. How much paint should Hans buy? Explain. So remember, we're only looking at the 18-inch situation here. So it's this right here, and this right here. And it's doubled that because it's got to go around, and then it's doubled that again because it's going to do twice. He's going to cover it twice, 2 coats of paint. So in other words, we need to find the area of, first off, we have to find the perimeter, whatever that perimeter is. Then we have to multiply that by 18 inches to get the area, and then we can figure out how much paint we need and then how many gallons or quarts that we need. All right, so notice that this part's straightforward. We have 42 here, and on the back side, 42. However, we need to find out how big or how long this is right here. So we have to use Pythagorean Theorem, and this forms a right triangle here. So if this is 28 there, so that has to be 14, is to find the height, we have the total height is 18 feet here, so from the tip down, and something over here is 9.5. So here is going to be roughly 8.5 feet there. So let's put 8.5 there. All right, so now we can use Pythagorean Theorem with the 14 and the 8.5 to find out the approximate length of just the side of the roof there, which I will call C squared. All right, then punching all that into a calculator, I get approximately, and I'm going to round up here just slightly, 16.4 feet. All right, so we're partying, yeah. Times 1.5, and that gives me 224.4. 224.4. Now, of course, we are going to be rounding up in just a moment. Now, what's this? 1 lap around. And we are using feet squared, so I will adjust that to say feet squared. So that's the area. So how much paint do we need? We have to double that because it says 2 coats. 2 coats will now give me, and to get 448.4 square feet. So now we look over here. We need to, if it's 448, how much do we need? Well, a quart covers this. So how many quarts do we need? So I'm going to take the 448.4, divide it by 175, divide by 175 to get our approximate 2.56 quarts. I almost feel like there should be more. Let's see if I've made any mistakes.
Why is it 448.4? Shouldn't it be 448.8?
Oh, thanks. All right, yep, quick change here. 0.8 right there. All right, so now we can answer the question, how much paint should Hans buy? He only needs less than 3 quarts. However, 4 quarts, which is 1 gallon, is cheaper than 3 quarts. So in the end, he's going to pay the $27.95. $27.95 plus tax and CRV and all that, of course. So buying less than 3 quarts, but the gallon he'll keep.